You already took attendance?
Yeah. Let me explain. I'll explain that in just a moment. Okay. Give me just a moment. Shut that down. Gonna hit done. We get these gentlemen. Okay. I see your hand, Mr. Thompson. Let me just do my intro real quick. Let me share my screen. Start the broadcast. Let me hop over here and optimize the video. Okay. Did I get my notification? I got my notification. I see your hand, Mr. Thompson. Got my audio. Let me see if I can get my image to push. That's fine. Okay. Let's see. Okay. Did I get my notification? Got my notification. I see your hand, Mr. Okay, I see it. Okay, that's all I needed. All right. So yeah. Welcome, gentlemen. So I'll check attendance again around the 15-minute mark. So I do my first wave, whoever's there, like right at the start. I usually try to do my first wave of attendance right at the start of class. And so basically I take attendance as I let you guys into the Zoom session. So if you make it into my Zoom and I don't say anything, that means you've gotten attendance credit for that day. And then, so like if you, like for instance, the time now is 6:03. So if anybody arrives at like 6:04, they need to kind of just stay in the waiting room until about the 15-minute mark, right? So obviously you don't want to miss that first 15 minutes. That's, that's where that kind of sets the stage for the day. The only way you're really not going to miss that, the recommendation is to be in the waiting room about 5 minutes before the start of class. That way, when I start right at 6, you already get your credit, you're good to go there. But yeah, I take attendance as I let you guys in, and then I check again around the 15-minute mark. After that 15-minute mark, you're lucky if you get attendance, right? So I think that was it. So we're going to just kind of keep plugging and chugging along. Again, I encourage you all to watch my pre-recorded lectures and use those as the base. I'm just kind of doing this thing together. This isn't really official. This is just us doing our best to try to touch on each topic without rushing, right? I can be like, okay, hey, we're just going to rely solely on the video. I don't really want to do that. I want to just kind of keep going at this rhythm, and the main thing is we're trying to get you guys prepared for exam 1, which is about 2 weeks out. Okay. I saw a hand. I don't know if your question got answered or if your answer got questioned. I don't know. But yeah, as usual, if you have questions, feel free to unmute yourself. That's the recommendation to get my attention. You could type in the chat, but that has more of a delayed response. I did say, yes, go ahead.
Sorry, it kind of got answered, but it was just that I've been coming to class and I was never let out of the waiting room these past few class periods. And I got an email today, like with a warning about my attendance.
Yeah, it's a warning. So like that would happen if you show up after the 15-minute mark, because I definitely write it at 6 and then again at the 15-minute mark. So if you show up after that 15-minute mark, then it can be a hit or miss. Let's just talk about it. Just remind me towards the end, and I'll probably set it to excuse, and we'll just kind of like reset the whole thing, because I know we're still trying to get acclimated to everything. So I'm not gonna like hold it against you. I think that my image is not pushing. Seems like it started to, and then it stopped. But yeah, just kind of remind me towards the end of class. So like, yeah, if you got an academic warning or anything like that, just remind me, and we can kind of reset it so that, because basically, again, all that is just record keeping. It doesn't affect your grade. It only kind of comes into play if we accumulate too many unexcused absences, right? So just, again, like at the end of class, just remind me and we can kind of reset that.
All right.
And try again, okay? Let me see what's going on here. See if I can get this to work. Give me a second, guys, because I was looking for my confirmation and then it just stopped. And so it's doing that tantrum thing that it likes to do. Now, it could be that that's causing it. Come on. For my confirmation. Yeah, it's still okay. Okay. What could be causing it? I'll be right back, gentlemen. I don't know why it's not being pushed, but I can see that the image is not being pushed. Give me just a moment. I'll be right back. Let's do like this. Let me get these gentlemen in the waiting room. Yeah, I bet typically what I do is I check attendance twice. Right at the start of class, I do a first wave of whoever's there, and then I check it again around the 15-minute. I'm doing it a little bit early just because I saw these guys. So I'm gonna go ahead, get them. You see EF, this one. But again, I mean, attendance, the only way attendance really becomes an issue if we accumulate too many unexcused absences. It doesn't affect your grade. It's just that you might be booted from the course, right? And that will affect the money and the structure. So as long as you're just in a communication, I usually try to not let that be an issue. Like if you say, hey, I've been coming or whatever, I was like, okay, I'll take what is it called? In good faith or whatever. I'll be like, okay, that's fine. And then we'll set it to like a kind of reset it. And I usually try not to let that be too much of an issue. But again, I have to take attendance for record keeping. Let me try this again. Maybe this time I don't click on the optimize thing. So I'm just trying to get the image to push properly. But for whatever reason, moment. Okay, I can see that. So I'm just trying to get the image to push properly. Come on. I can see that. If I can see the next one, I think would be good. Is it notability? No? Okay. Okay, that looks good because that's where I am. Okay. So I got my confirmation. The image looks proper. We're gonna go with it for now. Let's see. Okay, so we officially finished. I had a Porky Pig moment right there. I could not get my words out. We officially finished or made our way through chapter 1, right? So with that one, that was basically, we looked at, the derivative. Again, to summarize, derivative is just the slope of the tangent line at a point. We saw the limit definition of derivative, where it was basically the limit as h tend to 0 of the difference quotient. And then we saw some shortcuts or properties or theorems, right? So how we can, given the function, we can quickly find the derivative instead of doing that, limit of the difference quotient definition, right? So we worked on shortcuts. So we're gonna take those properties and we're gonna take those shortcuts and extend it a little bit further. And so with chapter 2, we're going to be exploring some of these concepts around the exponential and log functions, right? So from college algebra, the exponential has a horizontal asymptote. As x goes to the far left, as x goes to negative infinity, the y gets closer and closer to 0. As x goes off to the far right, as x goes off to infinity, y goes to infinity, right? And then we'll kind of explore, the derivative in terms of exponents and logs, right? So with section 2.1, we'll look at the exponential and log functions of natural base E, okay? The goal is today we want to touch on two sections, 2.1 and 2.2. So when I get my alert for the halfway mark, we'll try to wrap up 2.1, and then we'll move into 2.2. And again, I'll check attendance again for people coming later around the 15-minute mark. And the reason I do this, when I first started streaming in the past, live streams, what kept happening was students were trickling in. Like one student would show up at 6:01, 6:02, 6:05. They would trickle in and it was very disruptive. I was like, okay, I can't keep stopping to take attendance. So what I do, the first wave right at the start of class as best I can. Once I've gotten everybody there, I go ahead and start my stream, and then I check again around the 15-minute mark. And then, so if you're late and it's before the 15-minute mark, you just have to stay in the waiting room and I'll get you in there. But after that 15-minute mark, if you show up, that can totally be a hit or miss because, we started at 6. But anyway, so some objectives here, graph and solve exponential functions of the natural base E and graph and solve log functions of the natural base E. Okay, let's keep going. So we have this definition. It says the natural base denoted E is the value given by the limit as n goes to infinity of this guy here. We have this 1 plus 1 over n to the power of n, right? So as n goes to infinity, this limit approaches this number 2.7182, yada, yada, yada. Okay. So, some mathematician was sitting around and they noticed this, right? They had this looks very similar to compound interest formula almost, right? But, if n were 1, you would get a result, then you let n be 2, then they just kept going and they said, okay, as n goes to infinity, they've noticed that this approaches this number. But the reason we talk about this has a lot of very unique properties, this natural base E, right? So let me see. So let's take a look. Let's start here. We have a quantity P growing continuously at an annual percentage rate R expressed as a decimal has a future value after T years given by this guy, right? So this is for exponential growth, right? Growing, So we have A equals PERT. It's similar to continuous compound interest. But when we're talking about growth conditions, we use this notation. Where A is the future amount, P is going to be the starting amount or the starting population. R is the rate expressed as a decimal, and T is the time in years, right? Okay. So here we have that Lewis invests $5,000 in an account that earns interest at an annual rate of 3.25%. Find the future value of his account after 5 years if the interest is compounded continuously, right? So for continuous compound interest, that's where PERT comes in. You should have this should be a review from college algebra. So continuous compound interest, we're gonna use, I just remember this A equals PERT, P-E to the RT, okay? It says find the future value, so they're asking us to solve for A. See the time, okay. So then after 5 years, so the amount in the account after 5 years, if he starts with $5,000 times E, the rate as a decimal. So we have 3.25%. You can look at that percent symbol as per 100, all right? So in other words, to convert that to a decimal, basically just divide by 100. So then as a decimal, that's going to be 0.0325, okay? And the time is 5 years, right? So E is like a function. It's not a variable in this context. It's a function. It's actually a function in the calculator, right? So let's just pull up the calculator. Let's see. Let me think how to do this. Basically, I need right here. That's fine. This one. It looks good. Let's reload and refresh. I love that the days are getting longer. This is my favorite time of year. Days are getting longer. It's getting warmer. I'm an outdoorsy nature kind of person. I remember when we first started the semester, it was super dark by now. But now it's it's still some light left. Boy, I love the summers. At the peak, it's 9 o'clock at night, and the sun is still up. I was like, oh, I just be out there just soaking it all up as much as I can. Okay, so we have this 5,000 times E. So I'm gonna hit second natural log, and then we have to the power of 0.0325 times 5. I'm gonna close off my parentheses, and we get this 5882.24, right? So we're gonna say approximately, let me see the time, let me check on you guys. $5,882.24, right? That's an approximation. Okay, let me check this really quickly so I can get any kind of latecomers. Okay, so we get this. Find the future value, 5882.24. You see it here, 5882.24. Okay. Let's see, let's hop here. Okay, let me do this. Let me stop this screen share. Hopefully that doesn't throw stuff off. Let me get these gentlemen. It's fine. Come on. This needs to be full screen. It looks good. And we are here. Okay. I got, oh, these guys are close. Now, I'm kind of hesitant in reminding you guys of this, but it's okay. This is remote asynchronous, right? And in that on each given day, really all I need is for you guys to just get your attendance credit, right? So once you've gotten your attendance credit now, he popped in and out. I'll go ahead and give him credit because I saw his name. There he is. Okay. So you don't have to stay, like, as long as you get your attendance credit, because these sessions are recorded, once you got your attendance, you're just checking in so that I know that you're okay, that you're alive. If you have questions, we at least for a moment can sync up, but you don't have to. But it's still a good idea to stay and hang around because I know students have questions. Let me see if I can disable that. That's cool. Okay. Let me share the screen. Start the broadcast. That's fine. Ooh, hopefully that doesn't mess it up because it was kind of throwing a tantrum last time. Okay, that's fine. I'm just trying to get my image back. Can I see my image? I'm just waiting on my confirmation. Let's see. Okay, I can see it there. I'm gonna go with it for right now. I'm just waiting on my confirmation. Oh, that's not a good sign. Let's see. All right, give me a second, because it's like I still hadn't figured out the nuance of what causes it to like push and what doesn't cause it to push. Let me try this really quickly. Let me stop my screen share and start it again. And I think it has something to do with notability. It's just temperamental. Like, let me get this student. Okay, I got him. Try this again. Start the broadcast. Affect anything? Yeah, just give me like 15 seconds. I know that's like eternity in internet world, but just give me like a few seconds just to see, make sure that this thing is pushing properly. Broadcast. Okay, I can see the image is good enough for me. Okay. All right. So yeah, I think we did this one, right? So the 5882, right? Let's go on to the next one. Quick checks I usually leave as an exercise for you all. So I'm gonna let that be. And let's look at this. So it says for any positive number x, a natural log or log base e of x is given by this guy, right? The equation y equals natural log of x is equivalent to, okay, let's kind of go back over this. So
Professor?
Yes.
I think my screen is frozen
What do you see?
because I only see example 1, the one that we just did.
Yeah, I see it too. I don't know why it's doing that. Okay, let me try.
Yeah, I also only see example 1, Professor.
Let me try rebooting this and see if that fixes it. Let me see if I go back. Okay, yeah, maybe it is notability. Maybe I'm focused on Zoom too much. Okay, let's try this again. So, can you see me like going through the slides now? Let's see.
No, sir. It's still on the same example 1.
Yeah, maybe it is notability. All right. Let's see. Only thing I can think to do is reboot, repush it. Let me Okay, let me do my Hail Mary. I'm gonna restart my device. That usually fixes it. I've just avoided because it kind of eats up so much time. But give me a moment. I'll be right back. Let me get the student. Stop the screen. But this is why I have my pre-recorded sessions. This is why I pre-record, because this stuff could be like this. I'll be right back. All right, gentlemen, we are back. Let's see if it works now. Usually, yeah, that usually works. Let me share my screen. Start the broadcast. But I avoid it obviously because it eats up a lot of time. But sometimes it's unavoidable. Okay, so we're gonna go with this. Seems like it's pretty good. So can you guys see my screen now? Let's see. Did I get everybody? Yeah, I got everybody. Let's go here. Come on. So maybe I just have to figure out maybe a different setup for it to be more stable. Come on. Let me see. Come on. So maybe I just have to figure out maybe a different setup. Yeah. So because of like the device behaving like this is why I've created pre-recorded videos, right? So even if we do have technical issues like this, anything that I was going to say is already available. That's why I rely on that just as a backup for stuff like this, because this is irritating, like that it eats up so much of my time. so much of the class time. And it's just technical stuff. It's not anything that you can really do anything about. Because you guys need to be able to see my screen. Let's see. Because you guys need to be able to see my screen. Let's try redoing this. Let's shut that down. Yeah, so we'll do the best that we can, but obviously whatever we don't do together, I do expect you to watch my pre-recorded lectures. Again, this is just us trying to fill it, but you know, sometimes the devices aren't like this. Come on. I wonder if I turn it off, will it help? Okay, now I can see that there. Now if I try it. Okay, let me see. I wonder if I turn it off, will it help? Okay, now I can see that there. Try it. Yeah, I don't know why the image isn't being pushed. What if I go like this? Okay, so in these instances, you know, I'm gonna have to rely on my pre-recorded lecture because obviously this is eating to our time. What else can I do? Let me shut this down. And I can't go directly there. Okay, so now I can see that. Now let's try. So now I can see it. Yeah. Let's try. So now I can finally see the image. So I'm just going to go with it. Again, yeah. So again, just as a disclaimer, because of like this kind of thing, this is why I created my pre-recorded lectures, because sometimes Mercury retrograde or whatever, the devices just throw tantrums. You know, all I did was just restart everything. I didn't really do anything different. But eventually the image did push. So whenever these things happen, I have to default to that's why I went on and made those videos in advance. And again, that's why I do not rely on this time together. We just do the best we can with what we have together. But the real thing is watching my pre-recorded lectures, take notes if you're in class, ask me questions, right? And then, you know, it's really designed to be independent. Us doing this together is just doing what we can together, right? Okay.
So I'm sorry, Professor, but I have a question because I received the email today, and I know like last time that I attended class that we had interruptions when a student was basically explaining about like how we spend too much class time on work that we already previously covered in my math lab, but I'm kind of confused because I was like, okay, so I don't really need to attend class and I could just review the lectures that we go over in class.
Yeah.
So like what?
So
can you explain that further?
Yeah, so the structure is I do expect you to watch my recordings, take notes if you're in class, and kind of move at that rhythm. But then at least just check in. So, right, this is actually asynchronous. So make sure to get your daily attendance credit, like you just get into the Zoom. Once you get into my Zoom, you've gotten your attendance credit for that day. If you feel confident or whatever, you're not obligated to stay, right? So this is just us.
Okay, that makes sense. That makes sense.
Yeah. So yeah, that's the long and short of it. Yeah, just get your attendance credit on a day-to-day and just stay on top of your assignments. That's the main structure. And then this is just us, touching bases, filling in gaps, answering questions. This is really just me making myself available for you guys. And I'm just filling it in with this, but we don't have to do this. Right?
Professor?
Go ahead.
I thought our attendance was checking in on Blackboard. We're not doing that anymore?
Yeah, I couldn't get that to work. I couldn't get it to work because some setting is turned off that the administrators have to turn on, and they just, for whatever reasons, are not really trying there. So I had to default. As long as you've been making it into my Zoom, I take attendance. If you're concerned about attendance, just remind me towards the end of class today, like if you got that warning thing, just hang around towards the end and I'll go back and, at least for the previous sessions, because I know we're still kind of getting acclimated to everything, I'll probably change all of those to excuse, right? But I just need to check in just to make sure you guys are okay. I don't want you to just be MIA, right? So each session, just check in, get your attendance. And if you got that warning, just again at the end of class, hang around. We can go back and we'll change them all to excuse, and it's kind of like resetting and restarting for everybody. That's at least that they're requested. Yeah, that's totally okay. Okay, so it looks like we finally got it operational, right? So we're gonna do the best we can with what we have. So then we have, and again, it's let's just kind of go because there's more I want to say there, but I'm gonna let it be. For any positive number x, the natural log or log base e of x is given by this guy, and it says y equals the natural log of x is equivalent to this. Okay, so here, by definition, the common log base e is what we mean by the natural log of x, right? So when we see ln, that's just the common log base e. And then I want to say from college algebra, we can rewrite these exponents as logs and vice versa, right? If suppose we started with the exponential form and we want to write it as a log, what we would do is swing the base of the exponent is now going to become the base of the log. And then we'll get something like this and vice versa, right? Let me kind of write it like this. So we can write exponents and logs. These are synonymous, right? So say we have log base e of x, and we wanted to write this as an exponential. Let's see. Log base e of x equals y. That's going to be equivalent to, now if we want to write this as an exponential, the base e swings to the right, and the y now becomes our exponent. So that's going to be synonymous with x equals e to the power of y, right? So these two expressions are the same. If we want to write the exponential as a log, again, the base of the exponent swings to the other side and it becomes the base of our log. So when we have log base e, that's the same as natural log, right? So these two expressions are the exact same thing, right? So, that's how we kind of flow between those, okay? But the main thing I wanted you to get from here was that log base e is how we define natural log. And then we can flow between the log form or the exponential form. And these two, in the way they're written, are synonymous, okay? So we're going to use these techniques, or we're going to use that property to kind of solve equations. So here we have, find each of the following. If necessary, use a calculator to approximate, right? Right. So say if we wanted to solve this, we could set it equal to y, right? Let me think about it. Here, let's the long and short is really that the logs and the e cancel it out, and it's really just 4. Let me see if I go do it this way. So natural log of e is the same as log base e of e to the 4, right? So I'm rewriting natural log as log base e. If I set this equal to y and rewrite it as an exponential, so then this e is going to swing over, right? So then we'll have e to the 4 equals e to the y. Then this is true if and only if y equals 4, right? So that's one way to do that by hand. Another way that's a lot more simple, right? I just wanted to give you that context. The copy. All right. Natural log and e cancel, and then the result is just 4. Okay. Let's see. Let's do part B. So if this is A, I'll do B here. So I'm going to rewrite that log as log base e of 1 equals, I'm going to set it equal to y. I'm going to rewrite it as an exponential. So then, let's see, that's already halfway. So then we have e to the y equals 1. So then e to what power gives us 1, right? So this is going to be basically e to the y equals e to the 0, right? Because e to the 0 is 1. So then y equals 0 in that case. So that's just the backstory. But generally speaking, the natural log of 1 or the log of 1 is 0, generally speaking. If we apply our shortcuts in part C, right? Go ahead.
Why is y to the e equal to e to the 0 power again?
So in other words, e to what power will give us a 1? E to the 0 power.
Okay.
That's just the property, and I just applied it. Here, natural log and e cancel each other out, and so you can just, that one is just going to be -1. Okay. So natural log and e are inverses of each other. Natural log of 20, I'm just going to say use a calculator. That's the calculator problem. And, you know, I think you can put that in your calculator. So we got 4, 0, and -1. Let's see what they say here. So if we set this equal to y, right, is equivalent, and then we rewrite it as an exponential. So I think that's what we did. We set the equation equal to y, then we rewrote it as an exponential. This is true if and only if y equals 4. All right. Similar deal here, right? We had e to the y equals 1. This is true if and only if y equals 0. Okay. Here, same deal. I didn't write this one out because I felt like it was getting redundant a little bit, but it's the same thing. If we rewrite this log as an exponential, that base e swings, we're going to have e to the y equals e to the -1. This is true if and only if y equals -1. And then for the last one, if we use a calculator, you know, you can confirm or deny that that actually works. Okay. Yeah. Okay, let's keep going. Properties, okay? So properties of natural log, we have the log of the product is the same as the sum of the logs. The log of the quotient is the same as the difference of the logs. The third property, the log of a power, is going to be the same as the power times the log. So in other words, this power can come in front. The natural log of e, they're inverses, so they cancel, so they become 1. Right? Properties 1, 2, and 3 require that m and n are positive. Okay, that's fine. Because we can't take the log of negative numbers. Okay, so these are just properties. So the log of the product is the same as the sum of the logs. The log of the quotient is the same as the difference of the logs. The log of the power is the power times the log, and the log of e is 1. They cancel each other out because they're inverses. The log of 1 is 0. Okay. Okay, so this here is property 6. It's called the change of base formula. We have the log of m base b. We can rewrite that as the log of m divided by the log of b. You can also write it, or here, let me say this way. This log you can rewrite as the natural log of m divided by the natural log of b. But that's also the same as the log of m divided by log of b. So that's the change of base formula. Like when you need to change the base, you can either write it as the natural log of m over natural log of b, or you can write it as the log of m over log of b. They give you the same. They will give you the same result in either case. So here, the natural log of e, again, they cancel each other out, so it's like the power comes in front. So then the natural log of e to the x is just x. And it's a similar story here because e and natural log are inverses of each other, so they essentially cancel each other, and we're left with just x. Okay. So we have those properties. It's kind of a mouthful. I don't know if it's like information overload for you guys or not, but I do feel like when you start working examples, which apparently I guess you guys have already done so, which is good. Okay, that's not a bad thing. It becomes like kind of second nature, right? It kind of becomes natural. Oh, that was not a joke. No pun intended. Okay, so given this law, actually, I want to kind of get to the next section. So I'm going to have to, I know we ate up a lot of time. I'm going to have to rely on my pre-recorded lectures for this one. I don't want to disrupt the stream. It seems like it's extra sensitive. I usually like to stop and do a new stream for the next section, but what I'm going to do is just let it keep running because it was so sensitive, and I don't want to start that whole thing over again. So let's go ahead and hop into the next section. And again, with the pre-recorded lectures, I took the time and went through all the details for each section so that when we experience stuff like this, make sure this is okay. Yeah. We can still do what we need to do and just not be limited by these experiences, right? Okay. So with the next section, we want to take a look at section 2.2, derivatives of exponential base e. I feel like I should have scanned. Let me do a quick scan of the previous section to just see if there's anything pertinent that we need to touch on. So yeah, I'm gonna have to rely on my recording there. The domain of the natural log is non-negative, so basically 0 to infinity. We can't take the log of negative numbers, so x has to be strictly positive. Okay, this is fine. We're gonna come back. We'll see that later. Another example. We do have this exponential growth rate and doubling time. This kind of comes out naturally. We do have that what r times c equals the natural log of 2. So where the capital T is the doubling time, the time it takes for something to double. If it's like exponential growth, we'll see. This will pop up. It pops up a couple of times throughout this, so we will revisit this, and you can kind of get by without that property because it will come out naturally. No pun intended again. I would like to go through this, but I'm going to have to rely on my recording. Okay, that's all I wanted to say there. So then with this one, let's use the remaining time for this. Okay. So 2.2 derivatives of exponential base e functions. So the objective here, we like to differentiate exponentials base e functions and solve applied problems involving exponential base e functions and their derivatives. Okay. So the derivative of a function given by this is itself, right? So because of this property of the exponential base e function, it's its own derivative. That's why it's like so popular in mathematics, right? So if our f of x is e to the x, then f prime is going to be itself, right? So what they're saying is if we looked at the exponential function base e and we pick a point, if we were to calculate the slope of the tangent line at that point, it should be whatever that point is. Like if, right, whatever that y value is, the slope should be the same as that y value, right? So it's just an interesting function, but that's a unique property. It's really interesting. It's unique to this function. Okay, so the main thing about the derivative of e to the x is the derivative is itself. Okay. So then here we're asked to find the derivative or dy by dx of this guy. Okay. So for part A, it's fine. So we have this y. We go to find dy by dx. This is basically 3 times the derivative of e, but the derivative of e is itself. So this is just going to be 3 e to the x. I think that's good. Can I paste? We'll check it in just a moment, you know, but let's keep going. B, all right, right? Can anybody tell me what property do we have to use if we're going to take this derivative? All right. So we have x squared times e. We have to use the product rule, right? So the product rule.
Yeah.
How does that go? Can you walk? How do we do the product rule when we take a derivative? Or how do you remember it? So when we go to do the product rule, right? It's what? The first times the derivative of the second plus the second times the derivative of the first, right? So dy by dx, the first is this guy, times the derivative of the second, which is this, plus the second times the derivative of the first. Okay. So then if we crunch those numbers, the x squared persists. E is its own derivative, so it just remains as e to the x. The derivative of x squared is going to be what? 2x. So we're going to have 2x e to the x. Okay. We could leave it there, or we could do x squared, factor out the e to the x. Something like that. Maybe move that to the front. Okay. So I feel like either of these should be acceptable for me. Paste. I'm gonna use this one right here. And then for C, okay, we can do, let's just go ahead and do the quotient rule, right? Since we just did the product rule, let's just do a demo on the quotient rule. Let me give myself a little bit of space. What I'm going to do is kind of shrink this down just a little bit. Kind of move it up some. Okay. And we'll try to work below it. So then when we go to find dy by dx, so the quotient rule, low d high minus high d low over low low. So what that means is the bottom times the derivative of the top, which is this, minus the top times the derivative of the bottom, which is this, all over the bottom squared. So then e is its own derivative. So we have x cubed e to the x. The derivative of x cubed is going to be what? 3x squared e to the x persists. Okay. And then on bottom, we have what? A power to a power multiply, so x to the power is 6. Okay. Now on top, it looks like we can factor out, we can do some factoring. Looks like we could factor out x squared e to the x on both terms. And we're left with x minus 3 over x to the 6. Okay. This x squared turns this 6 into a 4. And we're right there. Just out of space. Let me create some space for myself. So what I'm going to do is move this. I'm just going to move it for right now. I'm going to reposition it in just a moment. I'll write my final results. I wrote it a little bit out of order, but it's going to be equal to e to the x minus 3 over x to the power of 4. Okay. Let me paste. And I'm going to rearrange all this stuff. I'm going to kind of shrink it down some so I can get it to fit and then put it in the right order. Okay. So then let's see. This belongs like here. This goes goes like here. Pretty good. Then we're going to resize it, like basically just try to get it to fit within the space. Okay. All right. All right. So we got 3 e to the x times x squared plus 2x, and then that guy. Let's see, how do we do? Let's go to view, single page. We got 3, where is it? There it is. 3 e to the x times x squared plus 2x, and then this guy. All right, I think we got the same thing. Okay. All right. So we had a little bit of a rocky start, but I think we're kind of on our way now. Quick check I leave as an exercise for you all. And again, if anything is not clear, feel free to unmute yourself to stop me. We can go back and talk about it. We have this theorem, okay? So we saw where e is its own derivative, but what if we had e to some function, e to the power of a function? So then now we apply the chain rule to this, where it still holds that e is its own derivative, but now we say times f prime. In other words, the derivative of e to the u is still going to be itself times du. The derivative of e to the power of to some power is the product of e to that power and the derivative of the power, right? So it's still itself times f prime. Okay. So we're asked to differentiate here with respect to x. So for part A, dy by dx, that derivative is going to be itself, e to the 8x, times the derivative of the power is going to be 8. So I'm just going to put the 8 on the left. So we just did e times f prime. Okay, e times f prime there. Copy. All right, let's look at B. Okay, so when we go to find dy by dx, it's going this derivative is going to be itself, so e to the negative x squared plus 4x minus 7. But then we're going to say times the derivative of that f of x, right? So that's going to be minus 2x plus 4. And I'm going to just leave it like that. Okay. All right, and then for C, okay, so when we go to do dy by dx, let's clean it up. Dy by dx, we get the derivative of e is itself, so e to the power of square root of x squared minus 3. But then we need to say times the derivative of f of x. So that's to the power of a half. So the 1/2 comes down. We're going to have this x squared minus 3 to the power of a negative 1/2. And then we need to say times, because basically we're applying the chain rule twice. So then times 2x, all right? And then it looks like we can get some cancellations going on, where this is canceled by that 1/2. Okay. So ultimately, that's on bottom. It looks like we have x e to the square root of x squared minus 3 over x squared minus 3 and the square root there. Okay, a little bit funky, but it definitely happens, right? Okay, let's copy. Let's see, how do we do? So 8e to the 8x, you see it here. B, negative 2x plus 4 times the e to the function, okay? And then we get this guy, x e to there over there, okay? Well, we're actually almost done with this section. Yeah, that's about what we anticipated. So quick check 3, I usually leave that as an exercise. Let's look at this, right? So one of the last last concepts we talked about from chapter 1 were higher order derivatives, right? So this is the second derivative of y with respect to x. So given this function, all right, we basically just take the derivative twice. So let me start with the original. We have this y equals e to the negative 5x squared. So then the first derivative, the derivative is going to be itself times the derivative of f of x. So that's going to be a negative 10x. Okay. Then when we go to take the second derivative of y with respect to x, so now we have to apply the product rule, right? The first times the derivative of the second plus the second times the derivative of the first. So the first is this guy. The derivative of the second is going to be negative 10 plus the second, which is this guy. The derivative of the first, I mean, I guess we could just rewrite the line. It should be the same thing, right? So then it's going to be e to the negative 5x squared times a negative 10x, okay? It looks like both of these have that e to the minus 5x squared, and they both have a minus 10 that we can factor out. Okay, let's try to factor this. So then it looks like we could factor out a minus 10 e to the minus 5x squared from both terms. Let me highlight them. Here's the e, here's the minus 10. Here's the e, here I'm taking part of this with the minus 10. Okay. So then from the first term, it looks like we're left with a 1. Nope, undo. With the first term, it looks like we're left with a 1 there. The second one was left over. It looks like it's a plus. We took out what? 1 negative. So then it's going to be minus 10x squared, right? Is what's left over. So minus 10x squared. Okay. Let's get rid of this. Let's paste. Okay, so we got minus 10e, blah, 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 times 1 minus 10x squared. Okay, let's see if we got it. Oh, let's see, was that not the end? There it is. Okay, we still had a negative, let's see. That's positive. Okay, we could have multiplied those double negatives to make it positive, and it should change that order. Like if we basically distribute a negative, it's going to become 10x squared minus 1, right? So I'll just do an aside to say that this is equal to 10e to the minus 5x squared times 10x squared minus 1, right? Basically, we distribute the negative into that parentheses, right? So they should be equal. And you see it here. Okay. Let's see what else we got. All right. So let's see. We have Franco's Fishing Emporium invested $50,000 into an account that earns 1.25% annual interest compounded continuously. The value of the account after 2 years is given by this. Find A of 5 and then A prime of 5 and interpret the meaning. Okay. So then for A of 5, what? That's going to be the amount in the account after 5 years with this structure, right? So that would be something you put in the calculator. And then the rate of change. So maybe we need to look at the derivative, right? So let's find A prime of t. Let's find A prime. Come on. So then A prime, let's see. So the 50,000 persists. E is its own derivative. So e to the 0.0125 t. But then we would say times the derivative of that exponent. So it's going to be times 0.0125. So where A of 5 tells us the amount in the account, this should tell us the rate of change, right? Again, that, you would just, from there, you would just use your calculator. Let's use our prepared notes and see what's going on there. So again, this just is basically comes from the calculator. That's how much is in the account after 5 years, $3,000. What's the rate here? 1.25. Okay. I was like, why is that so low? But yeah, right. So after 5 years, he's earned, the account has just generated $3,000 just for sitting there. And then let's see what happens here. We found A prime, right? And we got basically it's the same thing, but we multiplied by F prime, right? And so what this means that the account is increasing by this amount every year. So after exactly 5 years, the value of Frank's Fishing Emporium account is this. And that at that instance, the value is growing at a rate of this much per year, right? So that's the rate of change of the account at that instance. Okay, that wasn't too terribly bad. But the reason I kind of just brushed through it because a lot of those were calculated problems, right? Once we had the formula, they gave us the original formula, and then for the second one, we took the derivative, and then from that point here, we just needed to plug it in the calculator, right? So I don't know, you guys can do that. Okay. So we're a little bit early, even though we had all that other stuff going on. So yeah, let's go ahead and take some time. If you received an attendance warning, I'm probably going to go ahead and stop the live stream, and we can go student by student and just kind of reset it for people in attendance now. I'm going to say, hey, don't worry about it. We restart it. But again, the main structure is, at a minimum, I just need you guys to make sure to get your attendance credit. But once you get into my Zoom, that means you've gotten your attendance credit, because I take attendance as I let you guys into Zoom. I was trying to automate it before, but like I say, the administrator, there's something that the admins have to do that they just aren't really trying to do. Because when I researched it, I know exactly what it needs to be done. I just don't have access, so I can't do it. So since I can't automate the attendance, then I take it manually as I let you guys into my Zoom. So as long as you've been making it into my Zoom, you begin attendance. And if you're here and you say, hey, can we reset my Zoom? My attendance, then I'm just resetting your attendance, right? So, you ask and it's reset. Are there any questions about the content or anything else before I stop the stream? Going once. Okay. So on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Again, if you had the attendance thing, just hang tight and we'll kind of reset that for you guys. Okay. All right. So let's stop the stream.